Welcome to another proof, guys. I've been doing a lot of these lately and I'm really getting into them, so let's get straight into another one. So you've probably heard, or maybe not, of the logarithm change of base formula, and today I'm going to be proving it. Actually, I'm going to be deriving it, so if you haven't heard of it or if you're not familiar with it, then this will probably be a good opportunity for you to become exposed to it. Okay, so I'm going to define two variables. So I'm going to define two variables, y and z, let's call them. So for my first variable, y, I'm going to say that y is equal to the log base b of x. And y, b, x, z, they're all variables, so don't get caught up on which ones you use. It'll work either way. So I've defined y, now let's define z. So we could say that z is the log base a of x. Okay? Okay, so now given what we know, okay, we would know that z is equal to log base a of b to the y. And if you can't see that right away, let me write it in a different way. I could also write y is equal to log base b of x as x is equal to b to the power of y. They're saying the exact same thing. Essentially, this is saying that y is the power that b needs to be raised to reach x, which is just another way of saying, or probably the more concise or sensible way of saying, that y is equal to log base b of x. And similarly, you could just repeat the pattern here. So if z is log base a of x, then x is equal to a to the z, right? Because z is the power that a needs to be raised to reach a result of x. So all I did was I took this definition of z is equal to log base a of x, and I substituted in one of these x values, okay? Okay, so now let's use another property of logarithms that we know, okay? Log base a of b to the y, so a log base something of a variable to a power is equal to the power times the logarithm of the variable. So we could rewrite this as z is equal to y times log base a of b. Okay, so where do we go from here? Well, I know that I have a y that's being multiplied by log base a of b, and I already have a definition for y up here. I said that y is equal to log base b of x. So I could rewrite z as log base b of x times log base a of b. Okay. So now what would happen if I substituted in the original definition of z? Z is equal to log base a of x. It's right here. So let me do this up here. So that I could rewrite z now as log base a to x is equal to log base b to x times log base a to b. So now if I were to divide both sides by log base a to b, then I would get log base b of x is equal to log base a of x divided by log base a of b. So what this is essentially telling you is that if you have a log of some value to some other value, that you could use a log with any arbitrary base as long as you keep the base the same of the number of which you're taking the log divided by the log of the original base. So if that seems a little confusing, then let me help you out a little bit. Okay, so let's say that I wanted to find out what log base 12 of 24 is. Okay, so in this instance, my x value would be 24 and my b value would be 12. So all I need to do is pick an a, and usually there are two a's that are used. It's either 10, log base 10, which would be the common log, or it's e, log base e would be the natural logarithm. So I could rewrite this as one of two ways. I could say that log base 12 to 24 is equal to the common log of 24 divided by the common log of 12. Or if I defined a to be e, then I could say that this is equal to the natural logarithm of 24 divided by the natural logarithm of 12. And indeed, if you plug this into a calculator, you will find that log base 12 of 24, although I think the TI-84 is the only calculator that I'm aware of that could do log bases that aren't 10 or e, is equal to log 24 divided by log 12, which is also equal to the natural log of 24 divided by the natural log of 12. Anyway, guys, I hope that this helped. Drop a like or a comment on this video if it did help you, and I will see you guys in the next one. Take care.